Welcome to Make, a course taught at the University of South Florida. This tutorial is about using SD cards for data logging with the Arduino. We will discuss how SD cards work, how to communicate with SD cards, and then we will go into using SD cards for data logging and how to plot the logged data with a spreadsheet like Excel. This here shows the micro SD card adapter that we will be using in this tutorial. It's made by a company called Catalyx. It is widely available on the internet. We bought it from eBay. It came shipped from the US for about $5 including shipping. There are many vendors that offer it shipped from Hong Kong or places like that. But for pretty much the same money, if you pay some attention, you can also get it shipped from the US. Unfortunately, there is no English data sheet for this adapter, but we tested it now for quite a while and it seems to work very well with the sd.h library that comes with the Arduino. The great thing about this adapter is that it combines a SD card slot with a 3.3 volts to 5 volts level shifter. This is this little chip here. That is important if you use an Arduino that runs on 5 volts like the Arduino Uno that we're using in this tutorial. So this enables you to directly hook up this adapter to the SPI pins of the Arduino, and you don't have to worry about going from 5 volts to 3.3 volts. The SD cards, they all run on 3.3 volts, so this is why this is important. Another great thing about this adapter is that it uses the micro SD cards, and this card slot seems to be of fairly high quality, so the micro cards click in very nicely. It also has a 3.3 volts voltage regulator. That again makes it much simpler to use this adapter with the Arduino Uno. So we don't have to worry about 3.3 volts at all. There are also other adapters out there. Maybe the most notable one is the one from Adafruit. It's pretty much the same design. It also has a signal level shifter and a 3.3 voltage regulator, but it is $15 and we don't see a real advantage over the Catalyx model that we're using here. Here's an example of a SD card adapter that doesn't have a 3.3 to 5 volts level shifter. So here we only have the 3.3 volt regulator, but the level shifting is being done with resistors, and that means you need to add some diodes if you want to use it with a 5 volts Arduino to prevent the 5 volts from frying the 3.3 volts SD card that is sticking in the slot here when you use it. Since these adapters have almost the same price like the Catalyx adapter that was shown on the previous slide, we don't really recommend to buy these types of card readers. If you must use this model because you already have it, for example, then you really need to consider buying a separate 3.3 volts to 5 volt signal level shifter that you can have a reliable high-speed communication with the SD card. Let's have a look at the SD card's working principle. This block diagram is from the 2012 SanDisk micro SD card product manual. And so what you see here is that the card contains a bank of flash memory of the NAND type, and then there's also a controller which actually communicates with the outside world via a dedicated SD bus protocol or the standard SPI bus interface. This controller, once it receives data or a request for data, it then communicates with the blocks of flash memory and obtains the data and sends it out or puts in the received data. So on the Arduino, the SDH library, it uses the SPI protocol. So we will not use the SD bus protocol, but only the SPI protocol. There's one more thing to consider. Similar to the flash memory on the Arduino chips, all flash memory has only a limited number of writes per block, and so for these cards this is about 100,000, and so you might want to be careful how often you write to these cards in your loop. One should point out that similar to a standard hard drive, these controllers have actually a fairly sophisticated wear leveling management, and they try to spread out the block use across the entire flash memory, limiting the use for individual blocks. This can substantially increase the lifetime of such a SD card. Here are some things to consider when using SD cards with the Arduino. The most important item is that they need to be formatted in the file allocation table format, in short FAT format. When you buy a new card, then they're usually already FAT32 formatted and they should work right out of the box. If you have an older card and you need to erase it and format it, then on the Mac, when you use the disk utility, you need to make sure that the FAT format is selected. On PCs, this I believe is the default setting, so it just work right away. Many computers these days have a SD card slot, so you can just stick the card into that slot and then call the disk utility and format them. If there is no such slot, you can also get a USB adapter that takes these cards and then they just show up like a thumb drive. Okay, so once you have the card formatted and it's installed in the adapter, then we use the sd.h library on the Arduino. It comes standard with the Arduino integrated development environment, so after you install it, it should be present. There is a nice page about the SD library on the Arduino reference website. Okay, let's go there real quick. Here we are, and essentially what we have is two classes. The SD class that essentially deals with the cards, so you can see if there is a card present, you can initialize a card, you can make a directory and such things. And then we have the file class, and this file class that allows you to deal with individual files that are on the SD card. And so what we will use in the tutorial sketch is mainly the print ln method, which allows to print strings into a file, and that is very convenient if you want to create a human readable data log that is then very easily imported into a spreadsheet in Excel, for example. There are also some nice examples on this web page, so if you want to go beyond what we're discussing in this tutorial, these are some really good starting points for various applications of the card. There's also, for example, here the dump file and card info, where you can just get information on about the card or about a particular file that is on the card. Okay, one more word before we start discussing the sketch for this tutorial. If you're not familiar with libraries, objects, the SPI bus, or timed interrupts, then I recommend to visit makecourse.com and watch the pertaining videos. All of these things have their own video, and so that would get you up to speed to fully understand the sketch in this tutorial. The sketch itself is also posted. Just go to makecourse.com and seek out videos and then the SD card video, and on that page you will find the sketch that we are using in this tutorial. Okay, time to get going. So here you see the setup from the back. This is the card slot, and this here is the micro SD card, a 2 GB card, and this is the adapter for that card that I will be using to read it into my laptop. So let's stick the card in. Nice click. This here shows the wiring of this setup. Here we go from the 5 volts and ground pins of the Arduino, we go to the power rails of this breadboard, and we also go from the analog pin A0, we go to the swiper of this 10K potentiometer. So the outputs of the adapter, we have here the chip select pin. So this is connected to pin 10 of the Arduino. So essentially what we're doing here is just the standard Arduino SPI wiring. This here is the clock for the SPI bus, so that is connected to pin 12. And then we have the master out slave in MOSI and the master in slave out MISO data lines, and they are connected here to pin 11 and 12. And then there is 5 volts and ground, VCC and ground, and we just connect this to these 2 power rails. Now the potentiometer, as I just said, the swiper is connected here to A0, and the outer ends of the potentiometer resistor, they are connected to 0 and to 5 volts, so we get the entire 0 to 1023 range of the analog digital converter on the Arduino. Okay, now let's discuss the sketch for this tutorial. As usual, I start out with some notes about how to hook up things. This is what we just discussed with the photos. Then I start including the SD library, and I also include the timer1 library. We will use timer1 to trigger one sensor measurement every 500 milliseconds, so 2 times per second. It's always good to do things like that with a timed interrupt. That way you get the measurements done precisely in the time interval that you specify, and you're not depending on how quickly your main loop runs. There is a really nice tutorial on makecourse.com about timer1, where we use it to drive a 8x8 matrix LED display. So if you're not familiar with this library, then I recommend to visit makecourse.com and watch that tutorial. Okay, now a couple definitions. We define the chip select pin is number 10, so this is the standard SPI setup. And we also define here the potentiometer swiper pin, which is A0. We use that as a makeshift sensor input. Then we define 3 variables that are being used in the interrupt service routine. Remember, they need to be volatile. Again, if you're not familiar with interrupts and interrupt service routines, I recommend to watch the pertaining videos on makecourse.com that give basic introductions to how to use interrupts. So the first variable is the sensor value. So that's basically the potentiometer setting that we're reading out. Then we're also noting the time at which we read out the sensor value. So this allows us to do a data log that contains the time and the sensor value at that time. And we also need a flag in that interrupt service routine, which allows us to tell the main loop whether there is a new value measured or not. That needs to be written into the SD card. Okay, and then we go into the setup. And in the setup, we start the serial communication at 9600 baud. This allows us to print out some things so we know what's going on. And so we start immediately here by printing something, initializing SD card. Then we make the chip select line an output. There's an interesting bit of information on the SD page at arduino.cc, which says that apparently for using the sd.h library, even if you use a different pin as chip select, so something else than 10, then you still have to define 10 as an output. Otherwise, that library apparently is in trouble. Okay, so then we use the begin method of the SD class, and that initializes the communication with that SD card. This method returns 0 if it doesn't work, so with this not operator, this makes it a 1 in case it doesn't work. And so if it doesn't work, then we print card failed or not present. You can try that out by simply taking out your SD card, and then you will get this error message. Return then takes us out of the setup and dumps us into the main loop, where then we will get continuously printed the error message that we cannot communicate with the card. If it works, however, then we end up here, serial print ln card initialized, and so we will see on the serial monitor that the card was initialized. Here I check whether the data log.txt file is already there, and if it's there, I remove it, so that prevents from always appending to that file if you restart the sketch. And it also demonstrates, of course, 2 methods in the SD library, checking whether a file is there and deleting it. Here we initialize timer1 with 500,000 microseconds, so that takes us to a half-second intervals between interrupt calls. And so this means that every half second, timer 1 is calling the interrupt service routine. Then we read out the potentiometer swiper. Here we attach that interrupt routine, and I called it the read out potentiometer, and so we see it down here. And so in read out potentiometer, all we do is we read the analog pin A0 as we defined at the beginning of the sketch. We write that number into sensor value, and then we write down the time by asking the millis function what the current processor time is. Remember, this here simply counts in milliseconds starting from whenever the Arduino was turned on, and every 5 days approximately it goes back to 0 because we lapse. Then we set the sensor flag to 1, and that allows us to ask in the main loop whether a new sensor value has been measured. Now let's go to the main loop. Here we start out by instantiating a string object named dataString. Then we check whether the sensor flag is 1. So that's only 1 if there's a new value. And so if there's a new value, we go in here. And the first thing we do is we create a new data string, which is composed of the sensor time delimited with a comma and the sensor value. So we get 2 columns basically that are delimited with a comma. The first one is sensor time, the second one is the sensor value. Then we create a new file object named data file, which is done by using the open method of the SD class, so SD open, and then we basically if there is no data log .text file, we create one. If there is one, we simply append to it. This is specified with the file write definition. Then we reset the sensor flag to 0, right? Because we only want to do this once per new value. So we only write 1 line, and then we check whether this is a valid data file, if everything worked here with the open command. And then we use the println method on that data file object, and we print that data string at the end of that datalog.txt file. And after that, we close the file. It's always good to just open the file before acting on it and then closing it right after. This reduces possibilities for corrupting the file. Okay, once this is done, we also print that data string on the serial port so we can follow with the serial monitor what is going on. Should this here not work, if the data file would have not worked out, then we have here a error message which is printed onto the serial port. Okay, now it is time to fire this up and observe what the sketch can do. Okay, and I start up the serial monitor, and now I'm turning the potentiometer, and you see here card initialized, and now we see line after line being printed. And if you look real close, on the left you see the time count up, and on the right you see a value that is proportional to what I'm doing on the potentiometer. Okay, now we can take the card out and put it in the adapter for the computer. Now we put the card into the SD card slot. So I just opened the file with the text edit program, and you see we have here exactly the same lines that were just printed on the serial monitor. So this file is now just a text file with ASCII characters, and we have the time and the sensor reading delimited with a comma, and such files can be very easily imported into spreadsheet software like Excel. So I made a new workbook in Excel, and now let's see if we can import this file. So we select text file and we select import the file, and it's delimited. That's good. But it's delimited with a comma, and so when I click on comma now, watch what happens down there in the data preview. Here we get 2 columns, and now we can just finish this, and we get those 2 columns now on our spreadsheet. The first one is the timestamp, and the second one is the actual potentiometer swiper position. Okay, let's make a basic chart. So we select these two columns and we go here on chart and insert chart. And if you want to print one column against the other, you need to use the scatter type of chart. It's a little bit a strange name, but that's what it is. And so here now you see basically we plotted now the potentiometer swiper against the timestamp, and so you see I moved it over to one side and then back to the other and then one more time over, and then I stopped doing things. Okay, now you know how to log data with the Arduino and extract the data from the SD card and make a plot from that data. Pretty neat what one can do with an SD card. This concludes our tutorial using SD cards for data logging with the Arduino. Thanks for watching.